we've got a lot to cover, and like he said, we have very little time. So I appreciate it if you can grab the URL there, grab my coordinates. I'm online. If you have questions, comments, feedback, whatever, I'm happy to hear it. Is the microphone on? Everything okay? Okay, so if you've got questions, comments, feedback, whatever, I'm online. I'm happy to answer questions. I'm on Twitter. How many of you are on Twitter? 2016 Twitter? Anybody? Okay, good. Get on it. What about email? How many of you have email? Email. Anybody? If you're on either one of those, don't hesitate to ping me. I'm at your service. We're going to go through a lot of code. And the goal today is not to remember how to type everything that I'm going to type. It's to remember that you can type what I'm about to type, and that such a thing exists, and that there's a mechanism available for you. And if you want to learn more about that, you can deep dive first at that GitHub repository at the top there, where you'll find the code and a 3-day lab full of exercises that sort of repeat what we're going to talk about here in the space of 60 minutes. And also, there are guides, and these guides are all topical, 10 to 15-minute long sort of introductions to the various things that we're going to cover, begin to cover in the next 60 minutes. So there's that. A little bit about me. My name is Josh Long. Thank you so much for having me here today. I'm the Spring Developer Advocate on the Spring team. I'm an open source engineer and contributor. I've been, going on 7 years now. I've been the #1, top-ranked, highest-rated contributor of bugs, but still number one for 7 years in a row. More bugs per commit in the open source Spring projects like Spring Boot, Spring Batch, Spring Integration, Spring Cloud, Vaadin, Timeleaf Activity. I've caused more bugs in those projects than anybody else. I haven't fixed them, just created them. I'm also I'm a Spring evangelist and advocate, and that goes very nicely. It dovetails very nicely with what I do, along with amazing people like Trisha here as a Java champion, where we try and help the Java community find their way to a particular solution. Now, part of that, of course, is giving presentations like this and doing training videos. I just wrapped filming on the second installment of the Building Microservices with Spring Boot Live Lessons training video with my friend, the one, the only, the amazing, the inimitable Phil Webb. And I'm working on I'm wrapping up now my 5th book called Cloud Native Java. And for those of you who are wondering, since we're in that part of the world where this is actually sort of a thing that might be considered a neighbor, that bird is the blue-eared kingfisher. It's a bird that is indigenous or native, to use the English, to the Java Islands in Indonesia. So it's a bird that's native to Java. Now birds, you see, they fly. They project themselves through the air with the greatest of ease, often in the clouds. So this is a cloud native Java bird. It's a bird that's native. No, it's okay. It's fine. It'll come. Just give it time. You'll get it. So there's that. And I'm also lucky enough to work at Pivotal. How many of you know Pivotal? We're a small company with big dreams. We have a lot of great open source projects, some of which you may recognize on this slide. And we care about all the open source projects insofar as they serve our goal, the biggest goal, our raison d'etre, which is to help developers deliver value faster, to get to production faster, to move quickly and safely from product management all the way through the value chain, often to production. And we see that a lot of organizations struggle with this. They know that they need to be able to go faster, but they struggle with how to do that. They understand the existential threat implied by the organizations that are out there that are able to turn ideas into value quicker, right? A lot of these organizations are lucky enough to have sort of been around for a while. They've got software, large existing applications that predate the sort of era of cloud computing and the economics of cloud computing. These applications serve them well, and they're well designed for the time in which they're conceived, but now they present a bit of an obstacle. These applications are what we call monoliths, large unbroken code bases that have large teams of people that work on them. These applications are hard to evolve, to change. They're hard to maneuver and to react, to change in reaction to something in the marketplace. So these applications represent now a bit of a liability, a bit of a burden. So the question is, how can these organizations who are, they understand that speed is a differentiator. They understand that organizations like Netflix and Uber and Airbnb and so on, these are organizations that, though they're large now, they still deliver software as though they're small. They understand that being able to go fast and deliver fast software quickly is a differentiator, not just for the software, but for the business. So the question is, how can these organizations capture that same speed? And I think the size has a lot to do with it. Not the size of the code, but the size of the team. If you can factor out your code base, divide it into small enough batches so that a small group of people can work on it, you make it much easier for the people on that team to reason about the sort of scope of changes, to reason about what will break if you change something, to reason about testing, to reason about security, all that stuff, to be able to ship it, manage it, and so on. It's much easier to make changes to something and then see that change delivered and realized in production. Small code bases make it easier for small teams. Small teams have less requirements for communication and synchronization. It becomes easier to evolve that code base. This allows people to go faster. They can stay in their own sort of proverbial swim lane, right? I'm sure you've heard this idea reflected before. I'm going to go ahead and say the C word now. Conway. It's called this idea. What I've just described is it's also been called the reverse Conway maneuver, right? Named of course for Mel Conway, who in the 1970s. Did you hear that? Named, of course, for Mel Conway, who in the 1970s said that software is a mirror image of this organizational structure that it serves, right? It is the idea that if you have software that is built by different teams who are dysfunctional and they don't communicate well, your software will reflect that. And so if you want to fix the software, you fix the organizational structure. Things get better. This is not hard to imagine. They've done numerous tests, to confirm this. They did a test where they compared open source software to proprietary software of the analogous function. Imagine you had, for an instant, the opportunity to pull back the veil and look at the source code for Microsoft Office. After stifling the revulsion and the puke, what do you imagine you would see? If you could compare that to, for example, the code base for OpenOffice, something like that. What they discovered when they did the study, they realized that proprietary software, as developed by a proprietary sort of group with whose employees, whose people are sat in the same office, in the same time zone, in the same geography, in the same locale, speaking the same language, that software tends to have far less modularity, far less rigorous modularity. And this is because the group working on the code didn't need the API boundary to sort of define the swim lanes for their activities. If they changed something here and it broke something over there, no big deal. They pivot their chair and say, hey, Trisha, what do you think of this? I just changed this module. Can you change your thing? Whereas open source software, as developed by people in different time zones, different geographies and locales and languages, it's much harder for these people who contribute at different capacities. It's much harder for them to jump on a bridge line or to have an email thread to discuss these things, if they're available at all. Remember, people contribute at different time zones. Some people contribute in the weekend, some in the evening, some not at all for months at a time. For these groups, for these open source projects, communication is a synchronization point. It's a bottleneck, right? So if you have this problem, it becomes very useful to formalize the boundaries of the modules so that people who are working on those modules can stay in their own swim lane and the rest of the code base can depend on that solid contract. That's what we're trying to do here, is to reduce the cost of communication in an organization. And you do this by dividing your application into small pieces. One way to discover that small piece is by reading the amazing Dr. Eric Evans' tome, Domain-Driven Design. In that book, he talks about this idea of a bounded context, a part of the application that, when extracted from the larger whole, stands unto itself, internally consistent and reusable. A bounded context is really just making crisp a part of the domain. The common example, the one I'm sure we're all familiar with, is the idea of sales versus customer service. Nominally, in both contexts, you have this notion of a customer. But these are not the same thing. With sales, you're trying to incentivize somebody who has perhaps no knowledge of your product or you or of your organization to take a risk and plunk down some money and invest. Compare that with somebody who's irate. They've already got your product and they maybe want to be made whole. They want to get a refund or something like that, right? The way you treat these entities is very different. The life cycle of these different entities is very different. You can't assume things about the states of these different entities. And if you complicate your system by sharing one entity for both contexts, then you muddy the definition of what it means to be a customer. Maybe one should be called a lead and the other called an account or something. Make them more formal. Clear them up. If you can do this, you can identify things that can be treated as separate bits of functionality, small batches of work, small services. Small services upon which a small group of people or a small team can focus and work and deliver and iterate. And of course, the size of the group of people is kind of important, right? What is small? How small should that team be? Amazon.com founder Jeff Bezos talks about this. He talks about a 2 pizza box team. Now, I know that name, that definition is not very helpful, right? I give this talk in, other countries besides America, like this one, and they are not all in agreement about what 2 boxes of pizza means, because you see in America, where I come from, 2 boxes of pizza is a personal pizza, right? I saw a great fake. There's a Bill Murray parody account, and the other day, it's a parody account, but you can imagine him saying it. It's even better. It says, "Any pizza is a personal pizza if you believe in yourself and try hard." So true. Anyway, 2 pizza box team refers to generally 5, 6, 7 people, right? That includes developers, product management, user experience, everybody involved in the value chain of delivering software, co-located on the same team, so that the cost of synchronization and communication is very, very minimal, so that I can keep in my head what everybody else is doing. Netflix talks about the same they arrive at the same basic idea. They talk about a feature team, a team focused not on software versus product management versus operations versus security versus whatever, but instead on a feature. This is the catalog team, this is the streaming team, this is the whatever, right? Everybody involved in that particular feature, focused on that deliverable. So the size is what's really important here. So okay, let's say you understand this. Let's say we're on the same page about this and you get that the goal here is to make it easier for organizations and for teams to go faster, to optimize for human potential. We need to take our existing application, decompose it. And once you've done that, you run headlong into a couple of issues, 2 big issues that I at least see very commonly. The first issue is how quickly can you stand up a production-worthy service? What we're talking about is teasing apart these different pieces of the code into separate, standalone, independently deployable, internally consistent, reusable, bounded contexts. That implies, by definition, that you've got new services. They're talking to each other, right? You've got new services, and that means that for every service, you have to redo all the sort of non-functional requirements that every service you deploy into production has to have, right? It's not enough to say we're going to move to microservices, and oh yeah, all those concerns that we had about security and monitoring and load balancing and all that stuff doesn't apply anymore. It's ridiculous. You still have to have that stuff, right? And it's redundant. You have to have it for every service now, not just once. So the cost has to be nil. It has to be as cheap as possible to meet those requirements, because otherwise you're not going to production. Nobody's going to let you. That service isn't ready. Forget about the business value. You have these non-functional requirements that you need to care for. Most organizations that I've been to, not yours of course, but most organizations I've been to, has a terrible, dreaded wiki page. The wiki page with 500 easy steps to production. That wiki page is the enemy of velocity. It's the thing that gates our ability to go faster, to deliver better software. So we need to make that as quick and cheap and easy to address as possible. And so for that, I like to talk about Spring Boot and Cloud Foundry. How many of you have ever used Spring? Let's try that. Okay. How many of you have ever used Spring Boot? Okay, good. And how many of you have ever, gone to production? Okay, just making sure. Good. So there's that. That's a great way to stand up a single service. That's the first thing you need to address. The second thing you need to address is, now that you've done this, now that you've got lots of small services, each of which has these non-functional requirements, it's production worthy. Now you have services that are communicating with each other over the internet, over the net, over network partitions in theory. You've found yourself very squarely in the camp of distributed systems, and if there's anything, indeed, one thing upon which I'm sure we can all agree on, it's that building distributed systems is hard. So we need to get past that complexity as well. There is new complexity, right? We moved to this approach. It's not like it's free. You're now facing the laws of the fallacies of distributed computing. So you need to be able to address those and be an adult about it, right? So today we're going to look at that last point. We don't have enough time to do a full sort of 101 on Spring Boot and so on. But I'm going to assume you know some Spring Boot, and if you have questions, please feel free to wait until the end of the talk, and then we'll talk about them. I'm just kidding. You can ask them if you need to, but we have so little time. Okay, so we're going to go ahead and build a new service. We're going to start here at my favorite place on the internet. How many of you know? How many of you know this place? Okay, good. This is my second favorite place on the internet. My first favorite place is production. It should be your favorite place too. It's amazing. The weather's great. It's the happiest place on earth. It's better than Disneyland.
It's like Australia.
Yeah. Yeah. Anyway, he said wistfully, thinking about the current state of the US. So bookmark this, keep it close to your heart, keep it next to you at all times. What we're going to do is we're going to build a very simple service, and I don't care so much about the domain of the service or what we're going to do in the service. I just want to have something with which to play. So we're going to build a simple service. I'm going to call it the reservation service, and I'm going to use several things from the Spring Boot sort of catalog here. I'm going to use the DevTools support. I use Spring support for building web applications. I'll use Spring support for centralized configuration. I'll use Eureka for service registration and discovery. I'll use Zipkin for distributed tracing, RabbitMQ for stream processing, Actuator for operational concerns. I'll use H2, which is an in-memory embedded SQL database. So it's in-memory and embedded. It's going to lose all of its state after every restart. In this way, it's very similar to MongoDB. It just loses your data all the time. Very, very similar to MongoDB, just all the time. Yeah. Fine, it's not quite as JSON-y as Mongo. So there's that. And then we're going to use JPA, the Java Persistence API, because I make poor life decisions, that's why. So JPA. Now, naturally, you could elect to switch to the full version, and there you'll be greeted with an ocean of different checkboxes, things that you could elect to add above and beyond what we've talked about here, including MongoDB. It's a fine choice, of course. I recommend it for all your MongoDB use cases. So there's that, right? For our purposes, though, it suffices to leave things as they are. I'm going to go ahead and take a quick detour to talk about these three dropdowns. A lot of people get confused about these dropdowns. You see, they imply choice. This last one is a choice. I absolutely encourage you to take some time and use the language of your choice, at your discretion. I happen to be a big Kotlin fan. Who likes Kotlin? The rest of you are wrong. That's easy. So get on it. Java, Groovy, Kotlin, they're all fine. Scala and Scala, they also work well. Any language on the JVM that supports annotations and objects, right, will work just fine. So there's that. But these, my friends, these are not really choices. You could use these. These are choices. They seem like choices. They're dropdowns. But they're not really choices. These are non-choices. These are choices in the same way that stripping naked and running in traffic is a choice. You could, but don't. So, for example, what version of the JVM would you like to use in 2016? Both of these are end-of-lifed, no longer available, not supported, deprecated, past their due, past their prime, expired, stale, stinky. So to choose either one of these in 2016 is insane. To continue to use either one in 2016 is irresponsible. And I know all of you have moved to Java 8 except for those three people whose names I noted when we had that poll earlier. And then here we have the choice of packaging, and a lot of people don't know about this. They don't know when and where to choose which, so I'll do my level-headed best to explain. If by some crazy freak fluke of physics, you find yourself stuck in the very, very distant past, far, far, far beyond modern help, then choose .war. But if you're here with Trish and I, in 2016, nay, almost 2017, then choose .jar. This is a big part of my overarching guiding personal philosophy of make jar, not war. It's true. So, we're going to leave that as is. We're going to hit generate. Yes, ma'am. Oh, Santa Maria, she's right. So IntelliJ was one of the first to really, really offer great support for Spring Boot. And one of the ways they do that is they actually have a wizard, so file new Spring Starter project, and you'll get this. You'll actually get it's powered by the web service at start.spring.io. This is actually a web service. But now you don't have to leave your ID, you don't have to download the zip file, you don't have to open it, you don't have to import it. There's also support for auto-completion in there. And you'll see that later. But yeah, definitely IntelliJ is great. Jan Sebron from the IntelliJ team did a great webinar recently with Stefan Nicole. And if you want, the one-on-one on all the great integrations in the sort of ecosystem there inside of IntelliJ, definitely check that out. Is that okay?
Yes.
Okay, so I'm going to open this up. We'll open this up in my IDE, having done almost nothing yet, and we're just getting started. So I'm going to open this up in my IDE, my old one, my decrepit, creakingly old 16.2 release from like a month ago or something like that. What am I doing? Let's see. Goodbye to you. Very good. So what we're going to do, we have a build file. Hello, computer. We have a build file. This is a, can you see that in the back, my friend? Should I make it larger? A little bit. I can do that. I've got this. Technology. I know I could do the presentation mode, but I like to have the surrounding. Okay. Oh, is that okay? Fabu, good. So what I'm going to do is I'm going to go ahead and comment out the bits I don't need right now. For example, Zipkin, RabbitMQ. I'm not even sure if we're going to have time for RabbitMQ, but who knows. And we'll leave the rest of that in there. And I've got the dev tools here. So the dev tools are kind of nice. They let me just start the application once, compile, and then I can just destroy the Spring application context, and I don't have to restart the JVM. It turns out that a lot of the cost of restarting an application is just the JVM itself. If you've got a warmed up JVM and you just start Spring and then destroy the Spring application context, it's much faster, right? So let's go ahead and build a simple application. This is a Spring Boot application. You can tell it's a Spring Boot application because it says, it says Spring Boot application. I don't know what, yeah. So there's that. What I'm going to do is I'm going to build a simple entity. I'm going to build an entity of type reservation. I don't care about the domain so much. It's a JPA entity there, so there's that. I'm going to give it a primary key here, an auto-incrementing surrogate value, right, at generated value like this. We want to have a field here, another field to persist in the database, just something so that we have something with which to play. I'll create some getters. There's that. I'll create a constructor. I'll create another constructor, this time entirely for JPA. Right? I'll create a toString. There's this. Very good. So now I've got a very simple JPA entity. All that other noise is just for the purposes of Java. If you were using a more modern language like Groovy, Scala, Kotlin, or anything else really, that would be a one-liner data class in Kotlin and Scala, for example. And what I want to do is I want to save instances of this entity in the database. So I need a repository. Again, that's another domain-driven design kind of thing, right? So I'll create an object using Spring Data itself. Spring Data's JPA support. And in that project, we have support for different technologies, including JPA, and then we have this idea of a repository. These are interfaces, not implementations, just interfaces that you can provide, and that Spring will automatically implement for you. This interface, for example, will provide a find all, a save, a flush, etc. methods that will automatically be implemented for you. You can even provide custom finder methods. You can say find by reservation name string rn, etc. Right? There's that. So this will get turned into a method that looks like select all from reservations, where reservation name equals rn. And naturally, I could provide that query if I wanted to, etc. Right? So there's this. Now, what I want to do is I want to save some sample data in the database. So sample data CLR implements command line runner. And the command line runner is just a Spring Boot interface. It's a callback interface that when it's perceived on an object, Spring will call the run method, passing in the same public static void main string argument array, as the arguments here, right? So here's this args. Okay. Now what I want to do is I want to inject or work with that repository. So I'll say reservation repository. There's this. I'll create a constructor, and there we go. Spring will provide that collaborating object as a parameter to the constructor. In Spring 4.3, which just came out earlier this year, we don't need this annotation. Right? You may have seen that annotation in place before, but it's now no longer required, and I'm doing my best to try and forget to use it. I don't want to use it, but my habit is to use it, so you'll see me waffle a bit. Sorry. Okay. So let's see. Stream.of. My name is Josh. Nice to meet you. I'm joined by my pal Trisha, and that's the only friend I've got in the room. Who else is here? What else? What's your name, miss?
Rashmi.
How do you spell it?
R-A-S-H-M-I.
Very nice to meet you. Very good. Thank you. And what about you, miss?
Nasrin. N-I-S-R-I-N.
Like this?
S-R-I-N.
S-R-I-N. Sorry. Very good. Nice to meet you. What about you?
Andrew.
Nice to meet you. You?
Rishi.
How do you spell it?
R-I-S-H-I.
Like this?
Yep.
Very good. Nice to meet you. What about you?
Rupesh.
How do you spell it, my friend?
R-U-P-E-S-H.
R-U-P-E-S-H, like so. Very good. Nice to meet you. That is 7, right? We need one more. You with a beard.
John, S-H-Y-A-M.
S-H-Y,
Y-A-M.
like that?
A-M. Yep.
Very cool. That's a cool name. Okay, very good. So nice to meet you all. That's 8 names. It's nice and symmetric. It'll be fine. So there's that. And what I'm going to do is I'm going to save a record in the database here, just so we have some records to play with. Okay. Now this is just a simple, example. I'm just creating some sample data, and I should do this in a test, but I want to have something so that we can experiment. So I'll then visit every single record using another nice feature in Java 8 called lambdas. This is a nice feature that only the most modern of languages have. The languages that are the very vanguard of modernism. Languages like Lisp and Basic and C and Erlang and Go and Haskell and Forth and Basic and Visual Basic and TypeScript and LuaScript and Python and Ruby and PHP. I can't do it. It's not a language. It's not a language, whatever. Moving on, past PHP. I can never get to that part. Anyway, the point is these modern languages have this feature. So it's very nice that Java joins these other languages from the last 50 or 60 years in adding this feature. Now, what I'm going to do is I want to build a service, right? So we want to stand this up as a REST endpoint. And there's a few ways by which I could do this. I could go the long way around. I could say at REST controller class reservation REST controller, voila, and I can inject my reservation repository, and I can create a constructor there, and I'm going to create an endpoint that just returns all of the reservations like so, reservations, and I return the collection of reservation records, and I say this.reservation repository .find all, and that would certainly work. That's a REST endpoint that will give me a view of that data, but that's a lot of code. That's a lot of wasteful code, right? What I'm trying to do is to map the business state transitions, the read, the write, the updating, the deleting, to the appropriate and corresponding sort of methods on that repository. So why do I need the middle object? Why? Right? Let's just let the dumb machine do the dumb work, right? So instead, I'll use Spring Data REST. I'm not sure if I have that in the class path, actually. Nope, I've managed to forget that. So Spring Boot Starter Data REST, voila, okay? So now, I'll say repository, hello, repository REST resource, and I'll annotate this with @REST resource, path equals by -name, and we'll annotate this with @param rn. Okay, so that should do. We should have a simple REST API. Let's go ahead and spin it up and give it a go. I'll drink some water. Oh, can we open this door again? Is this going to alarm if I do this? Okay. Thank you. So, here we go. Localhost 8080/reservations. Okay, there's our simple API. There's all the data. There's all the things we expect. You may notice that there are the payloads, which we expect, right? But in addition to that, there's also these links. These links are hypermedia. They're an implementation of a design pattern called HATEOAS, or hypermedia as the engine of application state. It's the idea that every REST resource has information enough in the response for the client to be able to further manipulate that resource without any upfront or a priori knowledge. It's basically promoting self-describing REST APIs. This is a very useful thing in a distributed systems world when everything is a service. Remember, very few developers write documentation, and none, categorically zero, absolutely none, read it. So what you need to do is to make it as humane as possible for developers to consume these APIs. Hypermedia gives you that. This is when Dr. Roy Fielding introduced REST in his doctoral dissertation back in 2001, he talked about this. He talked about hypermedia, metadata about the resource, about the payload itself. So this is a good idea, right? We don't have too long to spend on this, but keep in mind that what we're using here is something called Spring HATEOAS. It's a layer on top of Spring MVC, which is the MVC framework. It provides a resource envelope object. The resource has a payload, which is the reservation, and links about that payload. We can contribute links dynamically based on the state of the resource, right? You can remove links or you can show links based on what is appropriate, what is a navigable state transition for that resource. So later on, we're gonna need to know that that's a resource, right? It's an envelope object called a resource, and we're gonna turn it back from JSON into a resource. Now then, I've got hypermedia. I've got a search endpoint. I can see that by going down here. It says search. If I go to the search endpoint, I got a finder method that says search by name. If I click on this, I say find by name rn equals my buddy Trisha here. Oops, come on, Josh, you can do this. There we go. So I did a search there, and there we go, right? So there's our simple API, okay? Now, are we done? Can we go to production yet? We're getting there, right? But not quite. There's still non-functional requirements. There's the things that we need to care about. So a cloud-native system is 4 things, at least for me. There's at least 4 things. One is it is observable. That is to say, you can understand what it's doing by monitoring its outputs, right? So I want to be able to understand what this service is doing. And who better than the service itself to tell me how that service is doing from an operations perspective? So we need to give that insight. I could have a monitoring agent sat in the same node, sort of adjacent to the running Java process. That gives me some visibility, or maybe a Java agent underneath the application. But these things have limited visibility into my application, and they certainly don't know about the nuances of my business logic. So my application's in a much better position to explain itself. So what I want to do is I want to give it that ability, and I have on the class path here the Actuator. The Actuator is a nice module inside of Spring Boot that serves exactly that goal. It's inspired by, among others, what Google does. Google has the Borg monitoring approach. They stipulate that for every service that they stand up, whether it's HTTP or big data or machine learning or web services or whatever the nature of that service is, they have HTTP endpoints at a well-known location. That centralized monitoring infrastructure can then come along and corral into a sort of unified dashboard experience. A single pane of glass, which is very useful, right, if you want to scale operations. I have that already embedded in the application. I can go here, I can go to /metrics. I can see that there are metrics that show me things like the memory, the heap, the non-heap, the code classes, etc. I've got env. Env shows me the environment of the application, right? I've got trace, which shows me the request log, the headers, the timestamps, the endpoints, the verbs, etc. I've got mappings. This shows me the endpoints of which Spring Boot and Spring itself is aware that are exposed to HTTP traffic. This is ideal for auditing, that kind of stuff. There's info. Now, info is necessarily left blank. It's up to you. It's like that page in the book. You're intended to customize this. You put identifying information about the service itself, maybe the build date or the git commit ID or the Maven version or whatever you need to identify that running service in production. Because when you've got a forest of services, HTTP processes, it becomes very hard to understand and remember which is which. So that's all there. And there's, of course, health. And health shows me different components, different subsystems in my application that are available, and their statuses. I want to be able to change these things, right? I can imagine wanting to customize these things. For example, I want to prefix my management endpoints and prefix it with /admin. Or maybe I want to customize this by contributing a custom health indicator, right? So there's a couple ways by which I can do this. The first way is just to contribute a property. So I can say management.contextPath equals admin. Did you see how cool that auto-completion list was? That's IntelliJ again, doing the right thing, TM. That auto-completion is driven by an SPI in Spring Boot itself. So IntelliJ, the Spring tool suite, which is an Eclipse distribution, NetBeans, they all use that same SPI to power their auto-completion. So that's one way to get, to customize the behavior of the application. Another is to just provide an object, right? This is Spring. It's a framework. So it is open for extension but closed for modification. You don't need to recompile Spring to change its default behavior, right? You can. It's open source, but you don't need to. So I can contribute an object of a well-known type, in this case, health indicator. And, that would do. So I can say, health dot status. And there's methods here. There's methods like down and out of service. And I know that these 3 methods are completely ludicrous for you. I know that your services never go down. I know that this is ridiculous, and I'm sorry. I have filed an issue saying that we should do better. We should just show you guys the up and status one. So for our purposes, I'll just say I heart Melbourne dot build et voila. Okay. So now I'm going to do that DevTools thing, right? Command F9. Here we are. Fail. Command F9. Oh. Okay. Command F9. I need some more of this apparently. So, good. Did that do it? Yep. Okay. No longer there. Good. Admin. Voila. And my custom health indicator, right? So I was able to change things by using properties and by contributing objects. This is the Spring Boot way. Now this property approach, it's kind of interesting. I can contribute things, I can change things by overriding the properties in the property file, but I'd have to recompile every time I did that if I wanted to see realized or reflected in the output a change. That's a non-starter, right? I don't want to have to recompile a jar for every environment. So one way to get around this is to use 12-factor style configuration. This is the idea that you have environment-specific configuration that is external to the build in, guess where, the environment, right? Well, that's a good idea, and Spring Boot supports that pretty readily. You can go to the command line here, downloads, reservation service, okay, and cd target, java minus jar, reservation service jar. Oh. May have been -d, skip tests, because YOLO. Clean install. Ain't nobody got time for that. Okay. Oh. CD target. I can run this application. This one here, I can say -d, server.port, for example, is a property that I may want to use. So I can say server.port equals 8010, right? That would work. I could override the default property by using a -d argument. I could use an environment variable. I could say export server_port equals 8030, and then just start Java after that. So any of these different ways would work, but this falls short of at least four different use cases. How do I change the configuration without having to tediously copy and paste it from one shell script to another? How do I centralize it? How do I support auditing and journaling? How do I see who changed what and when, and if necessary, to roll that configuration back? How do I support secure or encrypted information, things like passwords and locators, things I don't want laying around on the file system unencrypted and accessible? And how do I change the configuration whilst the service is running? By the way, are you cold? Should I close that? I see people, the cold chill of my talk is one thing, but I'm not sure about that. So I need to be, sorry? No, I'm going to be in a bit, but I'm just wondering if I'm the only one. So, yeah. So anyway, I want to be able to support these four use cases. And so while what I've shown you is a good start, it's not nearly enough. I think we need a little bit something better. One way to solve some of that is to support a directory full of configuration files. That would be a central directory. Then my different microservices could talk to that directory. That would get me part of the way. That would solve the centrality requirement. I could version control that directory using subversion. Don't do that. Or git. That would solve my auditing and journaling requirement. I could see who changed what and when, and if necessary, to roll that configuration back. But it still wouldn't give me what I need for security, right? If I have secure information laying around in the file system, how do I mediate access to that configuration set? And it wouldn't solve my desire to change configuration on the fly whilst the service is running. So for these use cases, I'm going to use the Spring Cloud config server. We'll go back to start.spring.io, or not. Hello? All right, who's torrenting? Okay, there we are. So I'm going to build a config service, and the config server is just that. It's a web service, it's a microservice that's going to manage access to a set of configuration, set of configuration that lives on the file system. And I'm going to go to github.com, Josh Long, beautiful, microservices, config. Oh, fail. Thank you, mob programmers. Very good. So there we are. Here we are. Grab that. And I'm going to clone this to my desktop here as /config. And I'm going to configure this newly minted config service. Nay. I'll say, abracadabra, you're a config server. Right? Then I'll point the config server to the directory full of configuration. Spring Cloud config server.git.uri, right? Yep. And I'll point it to the home directory /desktop/config. And I'll spin this up in port 8761, as is my custom. Okay, and we'll spin it up. So that's going to be a web service that other microservices are going to talk to. That microservice will give out sets of configuration, keys and values from these various configuration properties. So if I go to the desktop config here, I can see a bunch of property files. If I look at the property file called reservation-service.properties, I can see it's got a key called server.port and message and Spring Cloud Stream bindings. Whatever, all these are keys and values. So if I were a microservice that identified itself as whoops, I did that on the wrong one, port 8888. If I were a microservice that identified itself as, for example, reservation-service, what configuration set would I see? What information would I see? Well, I can confirm as much by going to 8888/reservation-service/default, right? This is the endpoint that I could visit to confirm that. So here, on port 8888, I can see there are two property files, one called reservation service and another one called application.properties. All microservices, no matter what their name, will see the properties from application.properties. All of them. It doesn't matter how they identify themselves. That's the sort of fallback values, the global values. Then we have this one. This is specific to a microservice that identifies itself as reservation-service. Only the microservice called reservation-service will see those keys and values. So I can see that I have a configuration value for port equaling 8000, and I've got access to this message. Let's go back to our reservation service here and teach it to take advantage of that configuration from the config server instead of in the property file in the jar itself. So we're going to say spring cloud config.uri equals, and we'll point it to the microservice that we've just spun up, and then we're going to give it a name. We're going to give our microservice a name itself, reservation-service. Now, it turns out that this would work even if I didn't provide that, because the default value is actually to look on localhost 8888. I do that because I care. I'm doing it for you. I'm a giver. Okay, so there's that. Now, whoops. That done, we should be able to change our code a little bit here to take advantage of the message that we've just created. So we can say @rest controller class message rest controller, and we can inject the value here, private final string value, create a constructor, tell Spring to @autowire the value as a parameter here. So like so, message, and all I'm going to do is I'm going to create an endpoint, get mapping, called message, that parrots the value that we've just injected, so we can confirm that everything is working as expected. So that message should be hello world. But I can imagine wanting to change this message, right? I can imagine wanting to override it later on. So let's make this refresh scoped, and then I'll do a command F9 again, and we'll see it go. Okay, there we go. 8000, right? No longer 8080. It's 8000 now. /message. And voila, there's our message. So we're getting the value from the config server. I can imagine wanting to change that configuration value. So what I'll do is I'll go to the config directory here. I'll say Joe reservation service.properties, hello Melbourne, extra exclamation marks, so as to reinforce my credentials and authority on Reddit. Okay. Git commit -a-m YOLO. Now, if I go to the config server here, localhost 8888 /reservation default, we can see it says hello Melbourne immediately. But my downstream microservice has no idea what's just happened. It doesn't know what's just happened, and it needs to be told what's happened. It's not constantly polling the downstream microservice. It's up to us to tell it, to redraw or refresh its configuration. And there's a couple ways by which we can do this. One is to use an event bus, the Spring Cloud event bus, or just trigger another one of those aforementioned Actuator endpoints, those operational endpoints that provide operational features. So what I'm going to do is I'm going to line these windows up. I'm going to send an empty HTTP post to the refresh endpoint, and then as fast as my little arthritic fingers will let me, I'm going to hit Command Tab and then Command R. Oh. Okay, ready? 1 for the money, 2 for the show, 3 to get ready, 4 to go. Good, all right. Good stuff, hot sauce. So thank you. He appreciates. Yeah, magic trick. So all I've done is I've reloaded the configuration in that one service without having to restart the process. I can see the changes reflected immediately. This supports things like feature flags. I can do A/B testing, right? This gives me the ability to decouple deployment of software from the release of that software. I have now the ability to have things baked into the working production build that aren't active for the whole population. I have a lot of features I can do here. By introducing a config service, I've also added a little bit of indirection between my microservice and the downstream directory, the repository of configuration. That indirection is an enviable place to do things like security. I can require that all communication from the config clients to the microservice, the config service, be secured and authenticated and over HTTPS. And even better, that config server can do things like symmetric encryption and decryption of encrypted values in the property files. So there's a whole lot more we could talk about here, but we don't have enough time. Let's move on. Now, the next thing that becomes very useful in a distributed system is making it easy for one service to find and work with another. Let's close this now. One thing that becomes very useful in a distributed system is making it easy for one service to find and work with another. In a distributed, cloud-based environment, things are going to come and go as demand and capacity dictate. So we need to make it so that if I call another service and that service has died or it's been moved to another IP or another node, things don't break, calamitously. We need to build a more resilient, more robust system. This is another key tenet of a cloud-native system. A cloud-native system is observable. It benefits from the horizontal scalability of a cloud environment. It is robust in the face of the ineluctable service outages and failures. And it is agile. That is to say, it's easy to evolve and change. So we need to care for that a little bit. How do we make it so that if that service isn't there, we can still find it and still call it? One way to solve that problem might be to use DNS. Instead of using straight IPs or ARP and then IPs, we could use DNS. This translates my logical name to an IP address, which I can then route to. But DNS has a fair number of limitations in the cloud environment. First of all, DNS requires a DNS server, obviously. But it's up to somebody else to manage that usually in an organization. It's not the developers, right? So that means you've got another ticket to file, another person to ask, another team to work with. Not necessarily a technical problem, but still something you should be aware of. Another problem with DNS is that it's slow. It adds a little bit of extra latency. It's a hop, naturally. That's the nature of physics. You have to, it takes time to call a service that needs to be called. You can get around that by caching the resolved IP addresses. So if I make a lookup for, IntelliJsAwesome.com, I get back an IP address. It's efficient to cache that IP address and then call that IP address directly again next time. But in a cloud environment where things come and go all the time, that's a bad idea. I may have a stale node. I don't want that, right? I can't afford that. The last thing I want is to build a system that calls a service that isn't there, that blocks, perhaps perpetually, right? We should, if we've all done the right thing, if we've all read, memorized, internalized, and applied Michael Nygaard's amazing tome, release it. How many of you have all read that book? I expect you keep it under your pillows. If you've all read, internalized, and applied that amazing tome, then you know that you have to specify aggressive client-side timeouts for all of the places where you have network connectivity. You've done that, right? Everywhere, everybody, all of your code and any of the parts of the application that use the JVM? Are you sure? Pop quiz, what's the default timeout for java.net whatever? Yeah, see, I don't like the answer. That wasn't very convincing at all, right? It's perpetual. It means it's going to block. You've got time bombs, right? You want to avoid that. You don't want to. I don't know how much your applications are worth when they're in production, but I know a lot of applications where if they have 100 threads and there's 101 requests and they're blocking perpetually, it's a lot of money, right? That's services being offline. So you want to avoid that limitation. It's much better to not call the service in the first place if you can avoid that. And that's a big problem with DNS. It doesn't give you the ability to answer the question, is that service there? Forget about where it lives. Is it there? If I make that call, will something on the other side respond? There's no awareness of the system itself, the topology of the system. Another problem with DNS is that aside from the latency that it introduces and the problems with clients that cache it and the fact that it doesn't really give us the ability to answer and ask interesting questions about the topology of the system, another problem with DNS is load balancers. Load balancers typically work with DNS. Fair enough, right? That's natural. But load balancers are pretty dumb, simple things. You have your F5, for example, and it'll be off on the side there, and it's got a few buttons that you can click or push to get certain configurations. You can do round-robin load balancing. Okay, fair enough. You can do sticky sessions for some well-defined notions of stickiness and session affinity. Maybe I've got a JSession ID cookie coming off the servlet stack. My application has generated that cookie. My client, my web application, has provided a cookie to the browser, and the browser is now transmitting that cookie, and some load balancers are smart enough to say, okay, I recognize that well-known type of cookie, I'll honor it and I'll pin that request to the particular node. But what about more interesting, more involved kinds of load balancing? What if you're trying to do data center aware load balancing? Maybe you're trying to load balance based on availability, or maybe you want to fail over to another node in another data center. What about load balancing based on some sort of business logic or heuristic, right? What about the Netflix use case? What if I'm a stateless client identifying itself with an OAuth token? How do I route that request to a particular node? Maybe I'm streaming a video. That's not something you just round robin load balance. You want to pin that request to a particular node. There's no Netflix button on your average load balancer, right? That's a business logic decision that you have to program. But you can't do that if you have that middleware in the middle. So we need to be able to control routing when it comes to service calls. This is very important for a lot of business applications. Maybe it's not for you, but it is very important for a lot. So for all these reasons and more, we need something a little bit more sophisticated than DNS inside the cloud, inside the service, inside the architecture. Obviously, for service calls outside of the cloud, for outside of the sort of your system, DNS is the only thing you've got, right? But for intra-service communication, we need something a little bit better. We can use a service registry. A service registry is a phone book for the cloud. It's a logical mapping from service ID to host and ports. So we can use any number of different service registries. Spring Cloud has an abstraction called the Discovery Client. You can use, for example, Apache Zookeeper, HashiCorp Console, etcd, you can use Cloud Foundry. And my favorite, we can use Netflix Eureka. Netflix Eureka is a good choice for two very, very simple reasons. The first is that it's been used by one of the largest websites on the planet for years without problems and without issues. So its qualifications are unchallenged, right? It's very, very good. It'll be fine, right? If you scale beyond Eureka, then I would have heard about you before, right? So that's the first reason why I'm happy with it. The second reason, and the much more important reason, is that it's super simple to set up, and I am nothing if not very lazy. So what we're going to do is we're going to build a Eureka service. I'm going to point it to the config server to draw its configuration. We'll hit generate. Okay. And I'll wait for, there we are. Spring.application.name equals Eureka-service. Spring.cloud.config.uri equals HTTP local. I don't care. It'll work. It's fine. Eureka service application, and I'll say @enable Eureka server, and go. So now that'll come on, go. That'll spin up in port 8761, localhost 8761, et voila, or not. There we are. So there's a few things we should notice about this. First of all, very well done mouse over. Very well done mouse over. That took time. We have people for that. Took a year. Took a year to get that. You have no idea. It was the wrong logo for like the first year. Anyway, whatever. And then second of all, no registered applications. Not yet, anyway. If there is one drawback to service registration and discovery, it's that it's invasive. You have to change your code to be aware of it, whereas DNS, for better or for worse, is handled sometimes incorrectly at the lower levels of your stack, usually in the operating system and in the JDK. So it's not really an issue that you have to deal with, even though it's the wrong behavior.